We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 15, Exercise 15.4. A plot is in the form of rectangle ABCD. So this is a rectangle having a semicircle on BC. So on this BC we have a semicircle as shown in the figure. If AB, this AB is 60 meter and this BC, AB is 60 meter and BC and of course AD, this is also 28 and this is also 60. Find the area of the plot. Find the area of the plot. So we have to find out the area of the plot. First, there are two figures here. First is the rectangle. Second is the semicircle. So what is the area of the rectangle? Area of the rectangle will be simply length into breadth, that is this 60 into 28. And then what is the area of this semicircle? Area of the circle is what? Pi r square. And what is the area of semicircle? It will be pi r square by 2. So what is the radius here? See, this is 28, this is the diameter. So radius will be 14. So it will be pi into 14 by 2. So when you compute this, 60 into 28 will be 1680, and this pi r square by 2, that is pi 22 by 7 into 14 by 2. 7 to the 14 to 2, 22 into 14 is 308. You just have to add 1680 with this 308 and this comes to be 1988 meters square. A playground has a shape of a rectangle. So here is a playground. It is a shape of a rectangle with two semicircles. So this is first semicircle, this is semicircle on its smaller sides as diameter added to its outside. If the sides of the rectangle are 36 and 24.5, so this is 36 and this is 24.5, find the area of the playground. Find the area of the playground. So this is the first area, and you have to just understand that this is a semicircle and this is also a semicircle. So when you have this semicircle, and if I combine this semicircle with this one, there's this second and third, if I combine, then this will be a full circle because the diameter is same for both of them. So we have this as 24.5, so radius will be 24.5 by 2. So the area of this second and 3 added will be pi r square. This will be 22 by 7. And what is this 24.5 by 2? You can write it as 49 by 4. So this is how we calculated pi r square, that is 2 plus 3. And this is going to be some value which is 471.625. And now this first part, which is length into breadth. So the area of this middle region, that is area of 1, will be equal to 36 into 24.5, and this is going to be 882. And we add these two, then we get this. We just add this 882 here, this one, and we get 1353.625 meters squared. Next is find the area of the circle in which the square of area this much is inscribed. So we have a circle and there we have a square being inscribed. So what is the area of the square? Area of the square is side square. Let us assume side to be A. So it will be A square, and this is given as 64. So A will be equal to under root 64. It is going to be 64 is 8 is the 64. A is 8. So the side of the square is 8. So this is 8, this is 8. Now this one, diagonal will be the diameter of the circle. So this is 8, this is 8, this is 90 degree. What this will be? Diagonal 8 square plus 8 square under root. I am using the Pythagoras theorem. So this will be 8 square plus 8 square. That will be 8 square 1 plus 1. And this 8 will come out. So under root 2. 8 under root 2 is the... See, whenever you have to find out the diagonal of a square, it will be just side root 2. Just remember this. So it will be 8 root 2. Now, what is the radius now? This is the diameter. So what will be the radius? It will be 8 root 2 by 2. So it will be 4 root 2. 4 root 2 is the radius of this circle. Now what is the area of the circle? it is pi r square. So pi is 3.14. It is given that you have to take 3.14 and 4 root 2 into 4 root 2. This is going to be 3.14 into 16 into root 2 is 2. And this is going to be 100.48 centimeter square. A rectangular piece is 20 meter long and 15 meter wide. From its four corners, quadrants of radii this much meter has been cut. Find the area of the remaining part. So here, if you see, we have a rectangular piece, and therefore 1, 2, 3 and 4 quadrants has been cut off. But if you see this quadrant, because they are having the same radius, so if I just take all these quadrants, say this one I'm taking, first one, it will come here. Second one I'm taking, it will come here. Third one will come here, and fourth one will come here. So essentially this 1, 2, 3, 4 will compound or will make a circle. So we have to find the area of this we already have this area of circle. So we just have to find out the remaining part. So how do you find out? First, let us find out the area of the circle. It will be, area of the circle is pi r square. Since the radius are same, radius is 3.5. So area of all the quadrants, say 4 quadrant, which is actually a square, which is actually a circle if you compound them, add them. So it will be pi r square. Pi is 22 by 7. Radius is what? 3.5. You can write it as 7 by 2, just to cancel things out. This is 11. 77 by 2. Now this is going to be 38.5. Now this is the area of 1, 2, 3, 4 part. And now what is the area of this rectangle? Area of rectangle will be what? This is length into breadth. Length into breadth. So 220 into 15. This is 20, and this is 15, and this is 20. So it is going to be 300. So just subtract this 1, 2, 3, 4 part. So subtract 38.5, and you will get 261.5 meters square as the area of the remaining part. In this figure, PQRS. So this PQRS is a square of side 4 centimeters. So the sides are 4 centimeters. So we have a square. Find the area of the shaded square. So we have a shaded portion, but inside this we have this one. So what we have to do, we have to find out the area of the square minus the area of these 4 quadrants. So area of, say, 4 quadrant, and subtract the area of this circle in between. So what is the area of this square? Because it is given 4, we know that the area of the square is side square. So it will be 4 into 4 side square minus area of 4 quadrant. Again, we have 4 quadrants, so 1, 2, 3, 4, they are making a circle because the radius are same. So what is the area of the circle? It will be pi r square. If you combine these all 4, so it will be pi r square. It is 3.14 into r. What is r? 1 into 1 minus. What is the area of the circle? See, the diameter is 2, so radius will be 1. So it will be pi r square, 1 into 1. So what do you get? You get 16. This is pi, and this is also pi. So you can just write it as 16 minus 2 pi. And if you want to compute, just place pi as 3.14, multiply it by 2, and subtract it from 16. 4 cows are tethered at 4 corners of a square plot of 50 meters. So we have these 4 cows here. So if a cow is being say tethered here, the cow may graze only this region, this portion. Same is the cow with this one, 4. And this is a square plot of 50 meter side. They just cannot reach one another. What area will be left ungrazed? So this area, this area, this area, this area, all will be grazed. Means they will eat the grass here. But this region will not be. This region will be left. So we have what we have to find out? Area of the square minus area of these 4 quadrants. And we already know the area of 4 quadrant, that is this one, this one, this one, this one, when the radius are same, they are going to be pi r square, area of a circle, so pi r square. So area of square is what? We have side, so 50 into 50 minus area of 4 quadrant, which is pi r square. Pi you can take it as 22 by 7, and now here, this is whole 50, so this will be 25, so it will be 25 into 25. So what do you get? You get 2500 minus 1964.29. This is going to be 535.71 meters square. A cow is tied. Here is a cow. It is tied with a rope. Again, same situation. When it is tied with rope, this is the only portion which the cow will be able to graze. At the corner of a rectangular field of dimensions is 20 by 16. So this is 20 by 16. 16 is total. 16 is total. 16 is total. Find the area of the field in which the cow can graze. So this is the area of the. This is the only area you have to find out. So you just don't have to subtract anything. So this is 14. So we know that the area of a sector is what? See, I'll just tell you that the area of a quadrant will be what? Because we are going to use it in all the questions coming after this. Area of a quadrant is theta by 360 into pi r square. But theta is 90 degree here. So it will be 90 by 360 into pi r square. This 90 by 360, 1 by 4. So every time I'll take a quadrant, whenever we'll take a quadrant, I'll just write 1 by 4. And this you have to assume that this has come from the formula, actual formula, theta by 360, that is 90 by 360, it is going to be 1 by 4 pi r square. Okay. So 1 by 5 pi r square you have to find out, this only region you have to find out. So it will be 1 by 4, pi is 22 by 7, radius is of course 14 into 14, 7 to the 14, 2 to the 4, 2 11s are 22, 14 into 11 is 154 this meter square. A calf is tied with a rope of length 6 meters. So here is a calf which is tied with a 6 meter length rope at the corner of a square grassy lawn of side 20 meter. The length of the rope is increased by 5.5. So the length of the rope was 6 L1, then L2 became 6 plus 5.5. So it has been increased. So previously it was 6, now it is 6 plus 5.5, that is it is 11.5 now, 11.5. Find the increase in the area of grassy lawn in which the calf can graze. So initially it was grazing on this one. Now when the length was increased, it is grazing on this one. So we have to find this area. So what we will do, first we'll find out the area of the bigger quadrant. Then that is this whole one. And then we'll subtract this one, smaller quadrant. So we'll get this one, right? So let us find out the area of the bigger quadrant, which is of course theta by 360, 90 by 360 into pi r square. That is 1 by 4 pi r square. So 1 by 4 pi. Now I'm taking the out means the longer one, pi r2 square. Let us say this is r2 and this is r1. So r2 square minus 1 by 4 pi, this r1 square. So 1 by 4 pi I'm taking out. R2 square is what? 11.5 whole square minus the lower one is 6 square. So what do you get? 11.5 minus 6 and 11.5 plus 6. Pi by 4 you can write 22 by 7 and here 4 also. So what do you get? This 22 by 7 into 4. 11.5 minus 6 is 5.5 and 11.5 plus 6 is 17.5. When you compute this is going to come as 75.625 meters square. A square water tank, this is a square water tank, has a side equal to 40 meter. There are 4 semicircular grassy plots. So these are 1, 2, 3, 4 semicircular grassy plots around it. Find the cost of turfing a plot at this rate, 1.25 per square meter. So what we have to do here is, see, we have to add these two areas. So if you take 1, 2, 3, 4 and if you combine it, this one and this one below 1. So I'm taking 1 and 2. So if you combine this will be one circle and I'm combining this 3 and 4. So if you take this 3 and you take 4, it will be again a circle. So you have a 2 circle which are exactly similar. So we have 2 circles here. So what is the area of 2 circle? 2 into pi r square. 2 into pi r square. I hope you got this idea, 2 into pi r square. This one, these two will be pi r square, these two will be pi r square, so there are 2, so 2 into pi r square. So compute 2 into pi is 3.14 and radius is of course, see, this is the diameter, it is 40. So what will be the radius? 40 by 2. So it will be 20 square, that is 400. So it is coming as 2512. Then we have this only, see, there are four grassy plots. So we have to just find out the cost of turfing the plot. So this is the only plot we have to consider. We don't have to go inside. So this is 2512 meter square. So for 1 meter square, the cost is 1.25 rupees or rate for 1 meter square. So what will be for this 2512? It will be 2512 into 1.25 rupees. This is going to come as 3140 rupees. Okay. A rectangular park is 100 meter by 50 meter. So this is 100 meter by 50 meter. It is surrounded by semicircular flower beds all around. So this one, this one, this one, this one. See here now the dimensions of the opposite semicircles have changed. Find the cost of leveling the semicircular flower beds at 60 paisa per square meter. 60 paisa per square meter. So now if you combine these two, say I'm taking this one 1 and 2. So if I combine these two, this will be one circle. This will be one circle. If I take 3 and 4, it will be one circle like this. So we have two different circles. So let us find out the area of this bigger circle. So it will be pi into r square. What is the r? See, this is 100. So what will be the radius? 100 by 2. This is 50. 50 square. Okay. 50 square. Now what is this one? These two? This will be another circle. And what is the radius? 50 is the diameter. So 50 by 2 is the radius. That is 50 by 2, 25. So it will be, we are adding these two. Pi into 25 square. Okay. Now when we just add them, this one is going to come as 7850 and this is going to come as 1962.5. When you add them, you're going to get 9812.5 meters square. So for 1 meter square, how much is the cost? 60 paisa. So let us convert it into rupees, 60 by 100. So for 1 meter we have 60 by 100. For this much meter, how much? 9812.5 into 60 by 100. And this is going to come as 5887.50. This is your answer. This is in rupees. The inside perimeter of a running track is 400 meter. The length of each of the straight portion is 90 meter and the end are semicircles. If the track is everywhere 14 meter wide, find the area of the track. Also find the length of the outer running track. So we have to find out the outer running track length, that is the perimeter of this, because inside perimeter is already given. It's 90. This from here to here it's 90. Let me show you. From here to here it is 90. From here to here it is 90. So 90 plus 90. Let me just assume that I'm taking the internal one. Internal say length or track. So this is the internal track. This is 90. This is 90. This we don't know. This we don't know. So how to find the interior one? Circumference of semicircular portion, this one. See, this is 90. This is 90. So we have 90 plus 90. That means this side is 90, this side is 90. We don't know this one. So let us assume it to be x. This is to be x. So just say that 90 plus 90 plus you have 2x. Let us assume that this is x, this is x, so 2x. This is equal to given 400. So 2x is 400 minus this 90 is 180. This is going to be 220 2x. So x is 110. So we have the circumference of this portion, half portion is 110. So now this is what? This is half of the circumference. So half of this circumference, which is 2 pi r, is 110. I am talking about this portion only, this portion. So this is going to be 110. What do you get? You can just put half into 2 into 22 by 7 into r equal to 110. You get r as 35 meter. So the radius is 35 meter. This radius is 35 meter for the internal semicircle. But this one is how much? The width is everywhere 14. So you just add 14 with this. This is r, which is 35, and this is 14. So 35 plus 14 is, this r is internal and this r will be external. E I am writing. R external will be 35 plus 14. So which is 49. Now, what is the length of the outer perimeter of both the semicircles? See, this I'm talking about and this I'm talking about. So it's a circle basically. If I combine these two, like this one and this one, it is a circle. So I have to find 2 pi r. 2 pi r of both of these, this one and this one. So 2 pi r, as I said, 2 into 22 into 22 by 7 into a radius. What is the radius of the outer one? 49. So 7 7 is 49. What do you get? You get 308. This one and this one. Now this is 308 and this is 90 and this is 90. So 308 plus 90 plus 90 will be the outer boundary or outer length, and this is going to come as 488. Okay, so we got the outer length. And what about the area now? What about the area of the track? So what we have to do, we have to take the outer area and we have to take the inner area and subtract it, then only we get the internal area. So from here we will take them separately. First this part and this part. So here the length is 90 and breadth is 14. So we have 1 and 2 parts. For 1 and 2 we have 90 into 14. This is the length and breadth, this is length and breadth, and we have 2 of these, so we multiply it by 2. Okay, this 2 into 90 into 14 is the area of this side. And how about this? If just see that I'm taking this part, half part, and this part, and I'm combining it. I'm taking the half apart. I'm just eliminating this one. So this will be actually a circle. So we just want to find out this region. So I have to subtract them. I want to have this region. So I'll take the area of the outer one and I have to take the area of inner one and subtract it. So what is the area of the outer one, which is pi r square, because I have made a circle out of these two. Combine this. So it will be pi r outer, r external square minus pi r internal square. So this will be what? I have to add these two. So this will be around, say, this one 90 into 14 into 2, and then we have 90 into 14 2. This is going to come as 2520. This will be 2520. And what about this one? Pi r e square minus pi r square. So it will be 22 by 7 into pi, that is pi I've already taken. R external is 49 square. This is outer one, this is 45, and this is 49, and this is internal one is 35. So 35 whole square. So when you solve it, it will come as 3696. So you have to add 3696 with this 2520. That means you have to add these two with these two, and you get the answer as 6216 meters square. Find the area of the figure in square centimeter correct to the 1 place of decimal. So what we have to do, we just have to take this area and this area, but we have something here also. Let me just join this. So we have joined this. So first area is this rectangle. First area is this rectangle. Actually it's not a rectangle, it's because this is 10, this is 10. So it's a square. So it's a square, 10 10, sides are same. So the area of the square plus area of this semicircle minus this area of the triangle, this is what we have to do. So what is the area of this semicircle? Let me write it as C. Area of the square is side square, so we have 10 10, so 10 into 10 is the area of square, plus what is the area of this semicircle? It is half into pi into r square. What is r? 10 by 2. Okay, now I have to subtract this triangle. Now is this triangle, we have this as 90 degree. So I can take this as base and this is as height, or this as base and this is height. So the area of triangle is half into base into altitude. So half into base into altitude. So 10 10 is 100. Then we have this, this will come as 39.28, and this will of course be 2 4s are 8, 6 4s are 24. So I have to subtract 24, and this will come as 115.3 centimeters square. In the figure, they form a rectangular region. Now here AB, CD with AB now as 20, a right angle AED. So this is a triangle right angle at this AED with AE as 9. This AE, this is 9, and this is 12. This is 12. On the other hand, taking BC as this diameter, we have made a circle, semicircle out of it. is added outside the region. Find the area of the shaded region. So we have to find out the area of the shaded region. Same thing we have to do, area of the rectangle, plus area of this semicircle and minus area of the triangle. This is what we have to do. So area of this rectangle will be simply 20 into this side, but this side we don't know. So how to find this side? Because if we find this side or this side, we'll be able to find out the radius also for this semicircle, and we'll be able to find out the breadth of this rectangular part also. So this is 9 and this is 12. What this will be? This is a right angle triangle. So this is 9 and this is 12. So what this will be? 9 square plus 12 square under root, right? So this is going to be 9 square plus 12 square. This will be 81. This will be 144. You add them, it will be under root 225, and this is going to come as 15 centimeters. So this side is 15 now. So we are now knowing this side. So we have area of rectangle as 20 into 15 plus area of the semicircle is half pi r square. So half pi into this is 15. So radius will be 15 by 2 whole square. And then we have to subtract the area of the triangle, which is, see, this is base, this is perpendicular because this is 90 degree. So half into 12 into 9, base into altitude. So this 20 into 15 will be 300. And this one will be, you can just write it as say 88.39, just compute it and just subtract it with this 54. This is going to come as 334.39 centimeters square. From each of the opposite side, two opposite side, these corners of a square of side 8 centimeters. So the square is of 8 centimeter. A quadrant of circle of radius. So there are quadrants, two quadrants of radius 1.4 centimeter is cut. Another circle of diameter 4.2. So this is a circle inside which is having a diameter of 4.2. Is also cut from the center. Find the area of the remaining or shaded portion. So what we will do, we'll find out the area of this square. Then we'll subtract the area of these two sectors. Let me say that area of two sector I'll be subtracting, and then subtracting the area of the circle inside. So first we have to find out the area of the sectors. So what is the area of the sector? We know that area of sector is 1 by 4 pi r square. Theta by 360 into pi r square. Theta here is 90 degrees, so it will be 90 by 360. That is going to be 1 by 4. 1 by 4 pi r square. But there are two sectors, 1 and 2. So I just multiply it by 2. There are two sectors. So it will be 1 by 2 pi r square. So let me, and what is the radius? It is given 1.4. So let me write now things. AS, which is the area of the square. What is the area of the square? It is going to be 8 into 8. Area of the square. Now minus area of the two sectors, which is half into pi into r square. What is the area, radius? It is given 1.4 into 1.4. And then we have to subtract the area of circle inside also. This is 4.2, so radius will be 2.1. So it will be pi into r square, 2.1 whole square. This you have to find out. So this is going to be 64, and this is going to be 3.08, and this is going to be 13.86. And you get 47.06 centimeters square as the result. In this figure ABCD is a rectangle with AB, this side as 14. This side is 14 and this is 7 centimeter. Taking DC, that is this one, and AD, this one, and this one, BC. These as diameters, semicircles are being drawn. So there is this semicircle, and this semicircle are being drawn. Find the area of the shaded portion. So we have to find out the area of shaded portion. So what we will do, we'll take this one, and this one. 3 will add and we'll subtract this region from here. Okay. So what I have to do here is, let me say that this is 1, this whole is 2, this is 3, and now this semicircle portion, which is white, you can see this is 4. So I have to add 1 and 2 and 3, then subtract the fourth one, which is the white one. Let us say that this is fourth one. So this we have to do. So what is 1 and 3? If I combine this from here, if I combine these two, it will be a circle, almost a complete circle. So what is the area? I can just say that 1 and 3 are, I can take pi r square. It is a circle. This and this combined are pi r square. So it will be pi r square. What is the radius? It is, the diameter is 7. So 7 by 2 whole square, pi r square. This we have done. Now let us come to this rectangle. Rectangle side is, this is 14 and this is 7. So just add 14 into 7, area of this rectangle. This is also done, this is also done. Now subtracting the area of this semicircle, which is white one. So the base is this one, DC 14, so radius is 7. So we have to subtract pi r square, 22 by 7, half of pi r square, half into 22 by 7 into r, which is 7. 14 by 2 is 7 into 7. So now this, what you get, this, all these things means this as first one, which I said is 7 by 2. So you said 2 into pi r square, which was actually pi r square, this one. So this comes to be 77 by 2, this one. Then 14 into 7 is of course the, or let me take this one. So we have to subtract this one. So 77 by 2, 14 into 7 is 98. And this one will be 77. Okay, 7, 7 to 11 and 7 into 11 is 77. So what do you get here for 59.5? This is the answer. In the figure, ABCD is a rectangle having AB equal to 20 centimeter and BC equal to 14. So here AB is 20, AB is 20 and this BC is 14. Two sectors 180 degree have been cut off. So there are two sectors, or you can say two semicircles these are. So they are being cut off. You have to find the area of the shaded region and length of the boundary of the shaded region. So now the boundary has to be found out. Area is very simple. Take the rectangle. So area of rectangle minus area of these two semicircles. So minus area of these two semicircles. What is the area of the rectangle? 20 into 14. You have to subtract the area of two semicircles. So if I combine these two, if I take this one first and the second, if I combine these two, what do we get? If we just combine these two, we get a circle. So this area will be pi r square, that is 22 by 7. And what is the radius? If this is diameter 14, radius will be 14 by 2, that is 7 into 7. So what do we get? This is 154. This is not 280. And this you go, so 22 into 7 is 154. So this is 126 centimeter square. So this is the shaded region. Now how about finding the length of the boundary of the shaded region? So we'll take DC plus AB plus this one plus this one. So I'll take this DC which is 20, again this AB which is 20. Then I have to take this one and this one, which is actually this one and this one, which is actually the circumference of the circle. So it is 2 pi r. It is only the circumference. So 2 into pi into r. What is the radius? 14 by 2, 7. So this will be 40 plus this will be 44. So you get 84 centimeter as the answer. In a figure this square ABCD is divided into 5 equal parts. So we have 5 equal parts here, all having same area. The central part is a circle, and the lines AE, this AE, and GC and BF, this one, and HD, this one, they lie along the diagonals AC and BD of the square. So if AB, this is 22 centimeter, find the circumference of the central part and the perimeter of part AB, this ABEF. So this we have to find, this we have to find. Main thing is this. Okay. So now, first of all, the circumference of the central part, what it is going to be. See, first of all, we have the side as AB as 22. So all the side, because it is a square, all the side will be 22. What is the area of this whole region? Area of this square will be side square, that is 22 square. So you get 484, which is area of this whole region. Now this is divided into 5 parts. 1, 2, this is 1, this is 2, this is 3, this is 4, and this is 5th part, 5 parts. So we have 484 by 5 parts. So one part will be this one also. So let us equate it to this pi r square. We have to find out the area of this circle. So I am equating this to the radius. This is a circle and this is one of the part, and so I have just taken 484, which is the area of whole one, and we divided into 5 parts. So one part will be, I divided it to 5, so one part will be there. It will be equal to pi r square. So pi is this, r square will be, let me write it, pi 22 by 7 into r square will be equal to 484 by 5. So r square will be 484 by 5 into 7 by 22. I'm taking root here, so r will come as 5.55. Now this, let me make it. So this radius is coming as 5.55. Radius is coming as 5.55. But if you see, this is 22, this is 22. What will be the length of the diagonal? What will be the length of the diagonal? We know that for a square, if this is A, this is A, this will be A root 2. So the length of the diagonal is 22 root 2. Length of the diagonal is 22 root 2. So we have to find out the circumference of the part. First let us find out the circumference, then we'll go to the next one. We already know the radius here, so 2 pi r will be the circumference. I'm first taking this one, then I'll go to this one. 2 pi r, so 2 into 22 by 7, we know the radius now, 5.55. So the circumference of the central part will be equal to 34.88. So first question is done. Coming to the perimeter of the part. So as I said that this is 22, this is 22, this will be 22 root 2. So this is 22 root 2. So what will be the half of this? 22 root 2 by 2, that is 11 root 2. So this half is 11 root 2. This is 11 root 2. But if this is 11 root 2 and we have a circle and the radius is 5.5. So what will be this? 11. This whole is from here to here, half 1. From this point to this point, it is 11 root 2. And from here to here, from this point to this point, it is 5.5. So this will be my BE and AE. So we have BE and AE, so multiplied by 2. So 2 into 11 root 2 minus 5.5 will be this one and this one. Now how about this one? 22. I am trying to find out the perimeter of the part, this part. So I have taken 22, I have taken this 2. Now I have to find out this side, this side. Now if you see, this is what? This will be 90 degree. This will be 90 degree. Okay, and we know the radius also. So we can find out the area of the sector or the length of the sector, EF. This one. So it will be theta by 360 into pi r. Theta is 90 degrees, so 1 by 4 into 2 pi r. Theta by 360 into 2 pi r is the length of the perimeter of the sector. So theta by 360, 90 by 360, 1 by 4, 2 pi r. 2 pi r, 2 into pi, 22 by 7 into r. And radius is what? 5.5. So what do you get? See, everything is there. The answer, if you compute it, this is going to come as 50.64. This is how we have to do it. In the given figure, find the area of the shaded region. Find the area of the shaded region. So this is the shaded region. And if you see, I have this one part, this two part. So if I combine 1 and 2, it will be a circle. Then this part and this part. If I combine 3 and 4, this will again be a circle. So I have actually two circles because this is 14, this is whole is 14, this is 3, this is 3. So 14 minus 3 minus 3, that is 14 minus 6, and it is going to be 8. So from here to here it is 8. From here to here it is 8. From this point to this point, 8. But we have this from here to here also, this is 8. From here to here it is also 8. What is the radius of each semicircle? What is the radius of each semicircle? It will be, see, this is 2. Okay, from here to here it is 2. This is 3 and this is 3. 14 minus 3 is 8. From here to here it is 8. So from here to here it is 4. This will be 2 and this will be 2. Then only it will make 8. Because this is a square inside. So we have 1, 2, 3, 4. If you combine this, there are two circles. Means this one and this one combine one circle, and 1 and 2. And 3 and 4 we combine, we have two circles. So we have two circles. So let us find out the area of two circles. 2 into pi r square into r square. What is the radius? 2. Okay. 2 into pi r square. So we have 2 into 3.14 into pi 4, 2 into 2. And this will be 25.12. How about this one? We have the area of this central portion also. So we have to take this area also. 4 into 4. That is this one, 4 into 4. So 4 into 4 is 16. That is area of the middle square, I'm saying. It is 16. So just combine this. You just combine this. This is going to come as 41.12. Now we have found the area of whole of this portion, and we know the area of the outer one, which is 14 into 14. Total area minus this area, 41.12. That is going to be 196 minus 41.12, and this will be 154.88 centimeters square. I hope you got the idea. How did we do it? This is 3. See, this is the side, which is 7. If you take the center one, this is 7. This is 3. So from here to here, it will be what? It will be 4. So this will be 2. This will be 2 because of the symmetry. Because of the symmetry I did. Now in the figure OACB, this is a quadrant of a circle with center O. So here we have a center O, and the radius is 3.5 centimeters. So if this OD is 2 centimeter, find the area of the quadrant OACB. So we have to find out the quadrant of first outer one, and then we have to take the shaded portion. So outer one we can easily find out. It is just theta by 360 into pi r square. Theta is 90. We just have to find out 1 by 4 pi, and outer one we have to find. So we will take this as 3.5. Outer one we have to find. So 3.5 whole square. This is going to come as 9.625. So in order to find out this internal, that is internal region, what we have to do? First sector, that is 1 by 4 pi r2, you can say. 1 by 2 pi r2 square minus 1 by 4 pi r1 square. 1 by 4 pi, or pi by 4 I am taking out. R2 is what? This is 3.5 whole square. And what is inside? 2 square. When you compute it, it is going to come as 6.482 centimeters square. In this figure, a square OACB, this is OACB, is inscribed in a quadrant OPBQ of a circle. If this QA, that is the side, which is the radius of this sector, is 20, no, this OA is 21, this one is 21. I don't know the radius. So this OA is 21, find the area of the shaded region. So what we'll do, we'll find out the area of the sector, and we'll subtract this area of the square, and we get the answer. Let me write it as square, and this as area of sector. So what is the area of sector? Theta, see, first this is 21 and this is 21 because this is a square. So what will this be? It will be 21 root 2. We know that the diagonal will be just side root 2. So we have now the radius also. So what is the area of this sector? It is theta by 360 into pi r square. Theta is 90 degrees. So we have 1 by 4 pi r square. R square. What is r? 21. We have to subtract the area of this square. What is the area of this square? What is the area of this? No, this is 21 root 2. Sorry. 21 root 2 into 21 root 2. So what is the area of this square? It is side square. So 21 into 21. So we have 1 by 4 pi 21 root 2 whole square minus 21 square. Same thing which I did. So you just compute it. It will come as 252 centimeter square. In this figure OACB, this is a figure. This is a square. So we have square of 7 centimeter side. If OAPC, that means this white region, if you see, is a quadrant of a circle with center O, then find the area of the shaded region. We have to find the area of the shaded region. So what we will do, we'll find out the area of the square, and we will subtract the area of the quadrant from here. So what is the area of the square? It is 7 into 7, right? And then we have to subtract the area of the quadrant, and it is given because theta by 360 into pi r square, theta is 90 degrees. So we get 1 by 4, 90 by 360, 1 by 4. So 1 by 4 into pi into r square. What is r? 7 into 7. This is 49 and this is 38.5. So what do you get? You get 10.5 centimeters square. In this figure OE, this one is 20 centimeter. In sector OSFT, this sector OSFT, square OEFG is inscribed. So there is a square being inscribed here. And then we have find the area of shaded region. This portion we have to find out. So we'll find out the area of the quadrant, and then we'll subtract the area of this square. It is given that it is a square. So what is the area of the quadrant? If you see area of the quadrant, for that, because only this 20 is given, the radius of the quadrant involves the radius. So we need to find out this radius. So this is 20 and this is also 20. So this is 20 and this is 20. This is 90 degree. So what will this be? Square, we know that the diagonal will be equal to the side root 2. So this will be 20 root 2. Now this is the radius now. So this is the radius of now the quadrant. So what is the area of the quadrant? It will be theta by 360 into pi r square. Theta is 90 degrees, so 90 by 360 into pi r square. So we get 1 by 4 pi r square. Pi is 22 by 7. You can write it as 3.14. And then 20 root 2 is the radius. So 20 root 2 into 20 root 2. And then you have to subtract the area of the square, which is 20 into 20. That is 20 into 20, 400. Let me write 400, 20 square. So this is going to come as 628. And this is of course 400. So you get 228 centimeters square. Find the area of the shaded region. If this AC is given as 24 centimeter and BC is 10 centimeter. And O is the center of the circle. So O is the center of the circle. So what we have to do, we have a semicircle here and we have a triangle. So area of this semicircle, that is ACB, or you can say AOBC. So area of the semicircle minus area of the triangle, that will give you the region here. But in order to find out the area of the semicircle, that is pi r square is the area of the circle and pi r square by 2 is the area of the semicircle. For this we need radius. So we have to find out the radius. For that we have 10 and 24. So what will be the diameter? This is 90 degrees. So we'll use the Pythagoras theorem. This will be 10 square plus 24 square under root. 10 square is 100. 24 square is 576. And you take under root. This is going to come as 676 under root, and this is 26. So you get the diameter as 26. So what will be the radius? It is 26 by 2. That is 13 is the radius. So now you can use here. Area of the semicircle will be pi r square by 2. So it will be half. Pi is 3.14 and radius is 13. So 13 into 13. And what you have to subtract? Area of the triangle. We know the area of triangle is half into base into altitude. What is the base? 10. Altitude is 24. You can take base as 24, altitude as 10. It depends on you. So half into 10 into 24. So what do you get here? You get this one as 265.33. And what do you get here? It will be 120. 2 tens are 20. 2 5s are 10 and 5 into 24 is 120. So you get 145.33 centimeters square. A circle is inscribed in an equilateral triangle ABC of side 12 centimeter, touching its side. Find the radius of the inscribed circle and the area of the shaded part. So here we have to do what? First of all, we know that the area of equilateral triangle, that is area of triangle, we have to find out, and then we have to subtract the area of the circle. So area of the triangle, we know that the area of the triangle, that is equilateral triangle, area is nothing but root 3 by 4 a square, that is side square, and side is given already. So we get root 3 by 4 into 12 square here, area of the triangle. Now, what is the area of the circle? For that we have to find out the radius. For that we have to find out the radius. So O is, because O is touching, means we have made a circle which is touching all the sides, and this is called as centroid. This point is centroid, and there is a property. The property is, if you drop a perpendicular, that is from A to this D, if you drop a perpendicular from this point to this point, and if this is the centroid, this divides the line into 1:3 ratio. So this part will be 1 by 3, and this part will be 2 by 3. So this is nothing but the radius only. So radius will be what? 1/3 of this AD, in this case AD. So how to find AD? The main thing is finding out the AD. So we have equilateral triangle, so this is 60 degree. See, this is 60 degree, right? And because we have dropped a perpendicular, the side is 12, so this will be 6, this will be 6. This will be 6, this will be 6. So for this triangle, let me take this triangle. So for this triangle, we have this as 60 degree, this as 6, and we have to find this one. Say it is altitude, h, let me take it as h. So tan 60 will be equal to h by 6, h by 6. So h will be equal to tan 60 is root 3, so 6 root 3 we get. And we have to find out the one third of this edge to find out this radius, OD. So let us take 1/3 of this, so it is 2 root 3. So we get radius as 2 root 3. This is the radius and this is 1/3 of this AD. AD we found out to be 6 root 3, we just took 1/3, so 2 root 3. So radius is, from here to here, it is 2 root 3. I hope you got the idea. Radius is 2 root 3. Now we are ready for the circle, pi r square. R is known. So pi 22/7 into r square, that is 2 root 3 whole square. So this will come to be, this if you compute, root 3/4, 12 square, it is going to come as 62.352. And if you compute this one, this is going to come as 37.714. Take the subtraction, you get 24.638 centimeters square. Okay, this will be your answer. In the figure, an equilateral triangle ABC of side 6 has been inscribed. Now the triangle is inside and there is a circle which is passing through here, right? So since we know that when we drop a perpendicular here, and if you join this one, this will be the radius. This will be the radius. And the equilateral triangle of side, so we know the side also, 6. From here to here it is 6, right? The side is this one. So what we have to do, first we have to find out the area of the circle. That is, area of the circle minus area of the triangle is this shaded region. So area of the circle will be simply pi r square, 22/7 into r square. R we don't know right now. So let me just take it as r square. And then area of triangle is of course root 3/2, root 3/4, a square. Side is given, 6 is given. So 6 square. So we are now in a position to find out this r. So we are drawing a perpendicular here, and this point, as we know, this point is nothing but, because this is the radius and this is also radius, so this is the radius. So if we have a triangle, that is the equilateral triangle, and we drop a perpendicular and we say from here we have drawn a line or draw a circle here. So this length will be 2/3 of this height. 2/3 if say this is AD. So this AO will be equal to 2/3 of this AD. That is the only thing, because we know that this is 1/3, so this is 2/3. So what is AD? AO, sorry, and AO is nothing but the radius. Okay, this is the radius, this is the radius, this is the radius. So AO will be 2/3 of AD. Now AD, for that AD again we'll take this triangle. This AD we have to find out. This is 60 degree equilateral triangle, and this is what? See here, the side is 6. So when we drop a perpendicular, that is this will be 3, this will be 3. So this will be 3. So tan 60, let me take it as h by 3. So h will be 3, tan 60 is root 3. So we have 3 root 3. Okay, h is 3 root 3. So now this h is 3 root 3 and this AO is 2/3 of h. So it will be 2/3 of 3 root 3. So we get 2 root 3 again here. 2 root 3. Now we can put it here. So 22/7 into 2 root 3 whole square minus root 3/4 into 6 square. So with this, what do you get? This one is 37.714. This you get as minus 15.588 and you get 22.126 centimeters square. A circular field, the circular field has a perimeter of 650 meters. So perimeter is nothing but the boundary, boundary is nothing but the circumference for a circle. So 2 pi r is given as 650. A square plot having its vertices on the circumference of the field is marked in the field. So we have a circular field, then we have a square plot having its vertices on the circumference. So this is a square here. Vertices are on the circle. Circumference of the field is marked in the field. Calculate the area of the square plot. Calculate the area of the square plot. So we have first the circular field perimeter. So 2 pi r is 650. This r will be equal to 650 by 2 pi. This is 660 by 2 and pi is 22 by 7. So R you get as, you can use this only, you get this only. So we'll use this. Now, in order to find out the area of this, we have to find what? Area of the circle minus area of the square. Area of the circle, we can easily find out, right? We know that area of the circle is what? But in this case, we have to find out what? We have to find out the area of this one. An area of the circle, because R is already known to us. So area of this square will be, we have to find out. First, this is the diagonal. So this is the diagonal, and we know this is, if this is a side A, this is a side A for a square, it is A root 2. So diagonal is, this is diagonal, but radius already we know. So this is diagonal and this is diameter also. So this is radius, so let us make it as 2R. So this 650 into 7 by 2 into 22 into 2, R into 2 is diameter, and this is nothing but equal to the diagonal. So diagonal is what? This much. Diagonal is this much. But we know that if diagonal, say this comes to be 2R comes to be 2275 by 11. So if this is a diagonal, it is A root 2. So we can, if A is the side, it is equal to A root 2. So in order to find out the side of the square, we just say 275 by 11 and we put root 2 in the denominator. So now the side can be found out, it is this one. So now what is the area of the square? It is this square. So 2275 by 11 root 2 whole square, and this is coming to be 21386.88. So this is the one, but we have to calculate the area of square plot, so we don't have to worry about this. We just have to find out this area of the square, which comes to be this one. Again, let me tell you that we drawn a circle, the perimeter is given, so we took 2 pi r equal to 650, we found out the r, and this is the radius. So this radius plus this radius, which is the diagonal or which is the diameter, is the diagonal of the square also. So diagonal of the square is A root 2 if the side is A, and this we found as it as 2r. So we just equated it and found the A, and then we computed A square. Find the area of the shaded region in this figure, where a circular arc of radius 7 cm has been drawn with a vertex A of an equilateral triangle ABC of side 14 cm as center. So here what we have to do, first we will find out the area of this triangle, area of this circle, we'll add them, that is area of the circle, area of the triangle, and then we'll subtract this area of sector. This we have to do. So the dimensions are given here because 14 is the side of the equilateral triangle, the 7 is the side, that is the radius of the circle. So area of the circle will be what? Pi r square. So it is simply pi r is 7, pi r square. Then we have area of the triangle. Area of the triangle is what? Because it is an equilateral triangle, root 3 by 4 into side square. Side is given as 14 into 14. Now what is the area of this sector? Because angle is given, so it will be theta by 360 into pi r square. What is pi? 22 by 7. And r is what? For that this is 7 into 7. So this comes to 154. This comes to 84.77, and this comes to this 360. This comes to 14 into 12. So this is 51.3. So when you compute this, this is going to come as 187.44 meters square. A regular hexagon is inscribed in a circle. So we have a regular hexagon which is inscribed in a circle. Hexagon is having 6 sides. Hex means 6 sides, and then the angle, all the angles are also same, and if you join these, there will be 6 triangles. 1, 2, 3, 4, 5, 6 of equal area. They are symmetric also, and they are congruent also. So we have to find the area of the circle. For finding the area of the circle, we need the radius. So the area of the hexagon, that is, if you take this one triangle, there are 6 triangles. 1, 2, 3, 4, 5, 6. So 6 into area of one triangle is equal to the area of the hexagon, which is given 24 root 3. So area of the triangle is what? Area of the area of OAB, that is this triangle, area of triangle is nothing but 24 root 3 by 6. So area of the triangle is 4 root 3. This is what we got. Now, area of hexagon, this, the area of this, as I said, this triangle is an equilateral triangle. Equilateral triangle. So in order to find out the side, we know that the area of the triangle is what? Root 3 by 4 a square. But we have known that the area of triangle is 4 root 3. So just equate it. Root 3 by 4 a square is equal to 4 root 3. But interestingly, this radius is nothing but, this side is nothing, this a is nothing but r. So radius and a, they both are same. In this case, this is radius, this is side of the triangle also. So we'll put r here. So r square will be 4 root 3 into 4 by root 3. So that is nothing but root 3 cancel, 4 square, r will be equal to 4. So we got the radius now. We got the radius. Now we can find out the circle, area of the circle. Area of the circle is simply pi r square. We know the radius. So pi is 3.14 and r is 4 into 4, that is, this is going to be 16. 4 into 4, that is 16. And this is going to be 50.24 square units. Okay. ABCDEF is a regular hexagon with center O. So we have a center O. If the area of the triangle OAB is given to be 9 centimeters square, find the area of the hexagon and the circle in which the hexagon is inscribed. Circle in which the hexagon is inscribed. So we have a circle outside, and then we have a, if I can draw a circle, there is a circle in which this hexagon is being inscribed. So we have to find out the area of the hexagon. As we know that area of the triangle is OAB. This is 9. So we have 6. We have how many? 6 triangles, and they are all exactly equal. So 6 into area of one triangle, that is 9. So area of the hexagon will be what? 6 into 9, that is 54. This is the area of the hexagon. This is done. Now circle in which the hexagon is inscribed. So for that we need the radius, and radius is nothing but the side of the equilateral triangle. So what is the area of the triangle, which is equilateral triangle? Root 3 by 4 into a square, and which is nothing but the r square also. Okay, r square or a square you can write, and this is equal to 9. It is given that the area of triangle is 9. Okay, so r and a both are same, so r square will directly use. So r square will be equal to 9 into 4 by root 3. So this will be 36 by root 3. R square we know, but we have to find out the area of the circle, which is pi r square, and we don't know that this r and a are both same. So in this r square we can put this one. So 22 by 7 into 36 by root 3. If you take value of this root 3, that is 1.732, you get 65.24 centimeters squared. This is the answer. 4 equal circles, each of radius 5 centimeters. So we have 4 equal circles, each are having radius 5 centimeter. Touch each other like this. Find the area included between them. So what we will do, see, first of all, this is 1 quadrant, this is 2 quadrant, this is 3 quadrant, and this is 4 quadrant. And as we know already that these 4 quadrant, 1, 2, 3, 4, if you combine them, they are making a circle. So we have to find out the area of the square, and then you subtract the area of the 4 quadrant, and which is nothing but the circle only. So what is the area of the square? What is the area of the square? Because the side is given. So this is 10. 5 plus 5, 10. So we have 10 into 10 is the area of square. And what is the area of 4 quadrant? It is pi r square. Because it is forming these all 1, 2, 3, 4 combined, making a circle only. So pi into radius is what? 5. 5 into 5. This is 100 minus 78.5. And this is going to be 21.5 centimeters square. And this is your answer. 4 equal circles. Now we have 4 equal circles, each of radius a. They touch each other. Show that the area between them is this much. So this circle, see, if you see this center being joined and the radius is a, the side of the square which is being formed here is 2a. So side of square being formed is 2a. So what we have to do is, we have to find the area of the square, and we have to subtract this 1, 2, 3, 4 quadrants from here. But the quadrant are nothing but a circle. If you combine these 4 quadrants, they will make a circle only. I hope you got the idea. So we have this 4 quadrants, that means this one, say let me take this one, 1, 2, 3 and 4. So 1 is this one, 2 is this one, 3 is this one, and 4 is this one. So they are forming a circle. So what is the area of the circle? Pi r square. What is the radius of the circle here? A. So pi a square. And what is the area of the, what we have to do is area of the square minus area of the 4 quadrant. So this is the area of the 4 quadrant, and this is the area of the square will be equal to 2a whole square, that is side square. So it will be 4a square. So we have to subtract these two. So 4a square minus this pi, that is 22 by 7a square. This is going to be 7 4 is 28 minus 22 by 7a square. And this is 6 by 7a square. This is what was expected. A child makes a poster on a chart paper drawing a square ABCD of side 14 centimeter. She draws 4 circles with center A, B, C, D here, in which she suggests different ways to save energy. The circles are drawn in such a way that each circle touches externally 2 of the 3 remaining circles in the given figure. If the shaded region of the in this region, she writes, save energy, find the perimeter and area of the shaded region. So perimeter, that means this length and this area. So area we have already seen that how to find out. We have already been provided these radius. So this side is 14, total side is 14 and the radius is 7. So we have to find out the area of the square in order to find out the middle region. So area of the square, then we have to subtract the area of the 4 quadrant here. Area of the square is what? Side is 14. So 14 into 14, that is 14 square, minus area of 4 quadrant. As I said, it will be combining to a single circle and radius is 7. So it will be 22 by 7, radius is 7 into 7. So this will be 196 and this will be 154. That is going to come as 42 centimeter square. So this is 42 centimeter square. This is the area. How about the perimeter of this one? See, if I combine these 4 quadrants, they'll form a circle. And we have to find out the internal lines, this one, that is this one, this one, this one and this one. So we have to find out the circumference. Eventually it is the circumference of the circle. So what is the circumference? It is 2 pi r. So 2 into 22 by 7 into radius, that is 7. So it will be 44 centimeter. The diameter of a coin is 1 centimeter. And if such 4 coins be placed on a table so that the rim of each touches that of the other 2, find the area of the shaded region. So we have this same thing which we just did now, and here what we will do, because the things are given, the diameter is 1 centimeter. The diameter is 1 centimeter, so the radius will be 0.5. Here also 0.5, 0.5, 0.5. And the square is being formed. What is the area of this square? See, this is 0.5, this is 0.5. So the side is 1. So 1 into 1 is 1 square is, side square is 1 square, that is 1. So area of the square is 1. And now to find out the area of the 4 quadrant, 1, 2, 3, 4, 2, 3, 4, they are forming a circle only. So it will be pi r square, means actually 4 quadrants. So 4 into 1 by 4 pi r square. That is coming to be pi r square only. So pi r square, 22 by 7, you can write it as 3.14 also. And r square, what is r? See, 0.5 is there. So 0.5 into 0.5 whole square. So what do you get? You get 0.7854 centimeter square. So in order to find out the middle area, you have to subtract this from this. So 1 minus 0.7854, this is going to come as 0.2146 centimeter square. 2 circular pieces of equal radius. These are 2 circular pieces of equal radius and maximum area. So all this is a cardboard. So there is a maximum area of circle. 2 circles are being taken off. Touching each other are cut out from a rectangular cardboard. The dimension is, this is 14 length and the height or the width is 7. Find the area of the remaining cardboard. So we have to find out the area of the square first, or rectangle, sorry. Then we have to subtract the area of two circles. So what is the area of the rectangle? It is length into breadth, so it will be 14 into 7 simply. So area of circle. So what is the area of the circle? One circle, let us find out. Area of the circle, we have to find out two of them. So 2 into, what is the area of one circle? Pi r square. What is the radius? From here to here it is 14. So the middle one will be, from here to here it will be 7. So the radius will be 7 by 2. So pi r square, that is 22 by 7 into r square, that is 7 by 2 whole square. So 14 into 7 is 98, minus this will come as 77, and this will be 21 centimeters square. In the figure, AB and CD are two diameters of a circle perpendicular to each other. These are diameter perpendicular to each other, and with OD as the diameter, this OD as the diameter, the smaller circle has been made. Find the area of the shaded portion. So here what we have to do, we have to find out the area of the bigger circle, this circle. So area of the bigger circle minus area of the smaller circle. Area of the smaller circle. So what is the area of the bigger circle? Because already it is given that this is 7 centimeter. If OA is 7 centimeter, so we have pi into r square. R is what? 7 square. Minus area of this smaller one. What is the area of the smaller one? This is 7. This is 7. So what is the radius of this circle? It will be 7 by 2. So it will be pi into 7 by 2 whole square. So what you have to do, 22 by 7, I am taking it out, 7 square minus 7 by 2 whole square. So this will be 7 square is 49, 7 square 49 by 4. And if you solve it, it is going to come as 115.5 centimeters square. Next is, in this figure, this PSR, RTQ and PAQ. These are three semicircles of diameter 10, 3 and 7. We have to find out the perimeter of the shaded region. So first perimeter means this will be the first semicircle. So area of, let me tell you, or let me just mark it, 1, 2 and 3. So first area, perimeter of the first one. Then we have to add the second one. And then we have to add the third one. So perimeter of a circle is 2 pi r. Perimeter of the semicircle will be 2 pi r by 2. So it will be pi r. So what will be the radius for the first one? See, it is 10. 10 is the diameter. So radius will be 10 by 2, that is 5. So we have pi into 5 plus. Coming to the second one, this one. So the radius is 3 by 2 because diameter is 3. So it will be pi 3 by 2 plus pi. Now coming to this one, third part, 7. So 7 by 2 is the radius. So pi into 7 by 2. So take pi common and just add this 5 plus 7 by 2 plus 3 by 2. So what do you get? Pi is 22 by 7. This is going to be 10. It will be 31.41 centimeter. So in this figure, two circles with centers A and B, they touch each other at a point. So we have a point C. If AC, this AC, total one, is 8 and this AB is 3. So total is from here to here it is 8, and from this point to this point this is 3. So here AC is 8, AB is 3. So what will be BC? BC will be this whole 8 minus 3. 8 minus 3. It will be 5. So 5 is the radius of the inner circle and 8 is the radius of the outer circle. We just have to find out the area of the outer minus area of the inner. Area will be what? Pi r square. So it will be pi r for the bigger one is 8 square and pi inner circle it will be 5 square. Just take pi outside, 8 is a 64 minus 5 is a 25. So you get 22 by 7 into 39. So this will be 122.57 centimeters square. Next is in this figure, ABCD is a square of side 2A. So ABCD is a square of side 2A. Find the ratio between the circumference. So we have 1 this one and 1 this one. So for circumference, and area of the inscribed and circumscribed circle. So in order to find out the area or any other thing, we have to find out the radius first. So this is the side, see, this is the side 2A and this is the side 2A. And we know that for a square, if side is A, the diagonal will be A root 2. So this is 2A and this is 2A, so the diagonal will be 2A root 2. Why? Because this is 2A, this is 2A. So this diagonal will be the actual radius of the bigger, it will be helpful for finding the radius of the bigger one and smaller one. So this is 2A root 2, this from here to here. So what is the radius of this circle? This one. What is the radius of this circle? It will be 2A root 2 by 2. So A root 2 is the radius of this circle. A root 2. So this is the, let us say it as capital R. Now we have to find out the radius of the inner circle. So we have this as 2A. This is 2A. So this will be A. This will be A. And this will be the radius. This is A. This is radius. And radius of this one will be what? This side is 2A from here to here. So what is this? This is half. This one is half of 2A. So this will be A. So radius of smaller circle will be A. Okay. So now let us find out the circumference ratio. Circumference of the outer circle will be 2 pi r by 2 pi small r. Capital R, this gets cancelled. Capital R is A root 2 and smaller r is A. So you get root 2 is to 1. Coming to the area of the incircle and area of the circumcircle, so pi r square. The circumcircle, so circumcircle is the outer one. So we have to take the incircle, that is the smaller one above and the larger one below. So that is why capital R is in the denominator. Pi cancels. So this r square will be this incircle. So this is the incircle. So pi a square, it will be a square, and this will be equal to, this is the circumcircle. So circumcircle is the bigger one. The radius is a root 2. So a root 2 whole square. So what do you get? It is a square by a square 2. So it is 1 is to 2. So it is not 2 is to 1, it will be 1 is to 2. Why? Because we have to change this. In area of the incircle to circumcircles, incircle is not root 2a, it's a. Small r is a, and this capital R is a root 2. So you just have to switch it off. And this is how, then switch it, and then 1 is to 2 will be there. In the figure, there are three semicircles, A, B and C, having diameter 3, 3, 3. Another semicircle, E, having a circle D, this one, with a diameter 4.5. So all the diameters, radius, etc. are given. Calculate the area of the shaded region. So how to find out the area of the shaded region? First of all, we will take this bigger semicircle. We will add this semicircle to it, and then we will subtract 1, 2, 3 from here. Okay, let me just name them. First is the bigger one, that is the main one. Then we have this is the second one. Then third one, fourth one, and fifth one. So we have to add 1 plus 2. We have to add 1 and 2. Let me write it here. 1 and 2. And then we have to subtract the 3 and these 4 and 5 from here. But if you see, this is also having radius 3 and this is also having radius 3. So these two are exactly similar. Even if you find out the area, it will be same. So let me just cut these two, because these two will get cancelled out. 2 and 3 cancel. So we have to find out 1 minus 4 minus 5. So what is the area of the bigger one? What is this? This is 9. From here to here it is 9. So it will be pi into area of the shaded portion. Okay. So pi into r. What is the r? 9 by 2 whole square. Minus 4. Let us take this one or this one, any of these. So it will be pi, and I am taking half outside. Why? Because it is a semicircle. So pi here, pi, this is 3. So pi 3 by 2 whole square. Then this one, and this is a bigger circle. So let me take this as 2 and this is 2, because it is a proper circle. So I have to add, I am just taking, this is pi square by r, pi r square by r, and now I am subtracting this one, pi into 4.5 by 2, pi into 4.5 by 2 whole square. This we have to do. Okay. So this will come, if you compute this, this is going to come as 99 by 8, which is going to come as 12.375. I hope you got the idea what we have done. We have taken the first total one here. Then we added this one, second one. Then we subtracted these three from here. But this one, they are exactly similar. So we can cancel these two or these two. So we cancel this. So 1 minus 4 minus 5, 1 means total one, that is pi, because it is semicircle, so pi by 2, 9 by 2 is the radius from here to here, it is whole square, minus this one, that is pi by 2, now the radius is 3 by 2 whole square, and again minus this whole circle, that is pi 4 by 2, 4.5 by 2 whole square. Okay, so when we compute this, we are going to get this 12.375 centimeter square. Now what is the rate of the painting? It is 25 paisa per centimeter square. So you just have to multiply this with 25 by 100, because 25 by 100 is in rupees, so it will be actually 0.25. So this will come as 3.09 rupees. Just say that it is 3 rupees. In the figure, ABC is a right angle triangle. Here, ABC is a right angle triangle. Angle B, this one, is 90 degree. BC, this BC is 21 centimeter. Now with AC as the diameter, a semicircle is being drawn with BC as the radius. BC, so there is a semicircle, and also with AC, a semicircle is drawn. So BC and AC, they both have a semicircle on it. Find the area of the shaded region correct to 2 decimal places. So what we have to do is, first, we'll try to find out the area of first region, that is because this is the shaded region, so this small portion is also included. This small portion is also included. So first we will find out the area of the triangle, this one. Then we'll find out the area of the semicircle, bigger semicircle, let us say it as 1 and this is 2. Now we have to add this with the area of semicircle, this one, and then we will subtract the area of this quadrant, this portion, white portion, area of the quadrant. So what is the area of triangle? It is 28 and 21 is already given, so half into base into altitude, 21 into 28. This will be the area of the triangle. What is the area of the semicircle? See, this is AC is the diameter. So first we have to find out the diameter. So 21, 28 is there. The diameter will be found using Pythagoras theorem. So it will be 21 square plus 28 square under root, and this will be 784. This will be 441. Adding to 1225, root of 1225 is 35. So 35 is this radius. So what is the area of this? Pi r square by 2. So it will be pi r square by 2, 22 by 7, half of 22 by 7 into 35 into 35. Because 35 is the diameter, so we have to find out radius, so it will be 35 by 2. Now we have to subtract what? Area of this quadrant. Area of this quadrant. So area of the quadrant will be what? It will be 1 by 4 pi r square. Theta by 360, theta is 90 degree. So theta by 360 into pi r square. So we have to subtract 1 by 4 into pi into r square. What is the radius of this one? It is already given, this 21. So 21 into 21. So this will come to be 294. Then we have plus, so we have to add this one. This will come as 481.25. 481.25. And we have to subtract this 1 by 4 pi r square. This will come as 346.5. And when you compute it, it is going to come as 428.75 centimeters square. Next is in this figure, O. O is the center of circular arc. So this is center. AOB is a straight line. This is a straight line. Find the perimeter and area of the shaded region correct to the 1 decimal plane. So first we'll try to find out the area. The area will be what? This is 12 and this is 16. So we need to have the area of the semicircle minus area of the triangle. This we have to do. So area of the semicircle will be what? For that we need radius. For finding the radius, because we have no radius here, but this triangle has hypotenuse as the diameter. So this is 12, this is 16. So this will be 12 square plus 16 square whole square, and this is going to come as under root 400, which is going to be 20. So 20 is the diameter, so 10 will be the radius. 10 will be the radius. So what is the area of the semicircle? It will be pi r square by 2. So pi 22 by 7 pi r square, that is 10 square by 2, minus area of the triangle is simple because base and altitude both are given 12 and 16. 12 into 16. So this will, if you compute this, this is going to come as, this whole will be 157.1, and this is of course 96. So this is 61.1 centimeter square. Okay, now we have to find out the perimeter also. What is the perimeter? Perimeter of this is first this half part, which is the semicircular part. So what is the perimeter? Perimeter is the length of this, the semicircular part, which is pi r, pi into r, plus 12 plus 16. So this plus this plus this. So plus 12 plus 16. This will be the perimeter. Pi is 3.14 and r is 10 plus 12 into 16, and this will come to be 59.4. This is the answer. In this figure, the boundary of the shaded region consists of 4 semicircular arcs, 1, 2, 3 and 4. The smallest 2 being equal. So these are equal. If the diameter of the largest is 14 centimeter, from this point to this point it is 14 centimeter, and the smallest is 3.5 centimeter. The smallest one, this is 3.5 centimeter. Find the length of the boundary and the area of the shaded region. So first we will find out the boundary of the outer one. That is, this is the first one, this is the second one, this is the third one, and this is the fourth one. So what is the length of the boundary? Because we know that the circumference of a circle is 2 pi r and the circumference of the semicircle is pi r. So we have to take pi outside and take r1, that is the radius of this one, which is 14 by 2. So 7 plus, I am taking pi r1 plus pi r2 like this. So I am taking pi out. The r is for the first one. Let us come to the second one. The 7 is the radius, so the 7 is the diameter, so radius will be 7 by 2. Then coming to this one, this is 3.5. 3.5, what is the radius? 3.5 by 2. So 3.5 by 2 plus 3.5 by 2, that is, there are 3 and 4, so I'll just multiply this with 2. Okay, so this is, again, this 3.5 can be written as 7 by 2. This is again 7 by 2 only. So 7 by 2 plus 7 by 2 is 7 only. 7 plus 7 is 14. So what do you get? 14 pi. 14 pi and 14 pi. So 22 by 7 into 14. 7 to the 14, 44 you get. So 44 is the perimeter, you can say, of the boundary. Now coming to the area. Area is what? For a semicircle, the area is pi r square. So same thing we'll do. Pi will take out. Oh, let me tell you first what we have to do. First we'll take the area of the first one, area of the second one, then we'll subtract the area of 3 and 4. Area of 3 and 4. So that is essentially equal to 1 plus 2 minus twice of 3, because 3 and 4 are exactly similar. So what is the area of the semicircle? Area of a circle is pi r square, area of the semicircle is pi r square by 2. So what we can do here is we can take pi by 2 outside and we can just deal with the radius. So what first radius is how much? This is 14. So it is 7 square plus. Now second one, this is the radius is 7 by 2. So you have a 7 by 2 whole square, that is 3.5 whole square, minus 2 into, why I am doing 2? I am taking these two together because they are exactly same. So radius is 3.5 by 2 whole square. Okay, when you compute it, put pi equal to 22 by 7 and you get the result as 86.625 centimeters square. In this figure, AB, this AB is 36 centimeter, M is the midpoint of AB. Semicircles are drawn on AB. This AB, AM and MB. A circle with center C touches all the three circles. Find the area of the shaded region. So by symmetry, one thing has to be noted here is, what is the diameter? Because this we already know. From here to here it is 36. From here to here it is 18. But how about this one? So because of this symmetry, if you see that this is one portion, this is another portion, this is another portion. So this is basically, if I just join this, these are three parts, 1, 2, 3. So 36 is the length. So if you divide it by 3, so we get 12. So this is the diameter. 12 is the diameter of the inner circle, this whole circle. So in order to find out the area of the shaded region, first we will find out the area of the semicircle, that is the bigger one, that is this one. Then we will subtract this 2 and 3, which are exactly similar, and this 3. So 1, this 4. So 1 minus 2 minus 3, this area, minus 4. So what is the area of the first one? We know that the area of a semicircle is pi r square by 2. So pi r square by 2, pi by 2 r square. What is the radius of this one? This is 36. So radius is 18 square. So it will be 18 square. I will take pi by, no, I will not take pi by 2 because pi will be coming here. So it will be pi by 2, 18 square minus. Now twice into, why I am doing twice? Because 2 and 3 are exactly similar. So 2 into pi by 2 into r square. What is the radius of this? This is 18. So radius will be 9 square. Now subtracting this one. As I said, the radius is what? 1 by 3rd of 36. I explained you how, 12. So this will be 12 and the diameter is 12. So radius will be 6. So it will be, again it is a circle. So I'll take full pi r square. Pi into 6 square. Okay, if I just compute this, this is going to be, if I just take this pi by pi like that only, if I don't multiply pi, it will be 45 pi. You can write it like this, centimeter square. In this figure, ABC, this ABC is a right angle triangle in which this angle A is 90 degree, AB is 21 centimeter, AC is 28 centimeter. Semicircles are described on AB, AC and BC. So we have this one, and this one. Find the area of the shaded region. So how we have to do it? First of all, we have to because this region can be only found when we take the area of we have to take out certain areas. First we have to add 3 areas, then subtract the third one. Okay, we have to find out the area of the shaded region. So for that, first of all, we have to compute the area of, first of all, we have to find out this length, because this is 21 and this is 28. This is not known to us. So this length will be 21 square plus 28 square. I'm using the Pythagoras theorem. And this is going to be 35. This is going to be 35. So what is the area of, I'm just, giving the names. So let us say that this is the longest one, or you can say the highest area one. Semicircle is 1. Then we have the area of the second one, then third one, and then we have a triangle, fourth one. So what we will do, first one, the area will be, what is this? This is pi r square. With this we have to, this area we have to find out, means the shaded region. So first we will find out the area of this first one, which is pi r square by 2. So pi r square by 2. What is the radius? See, this is 35. So it will be 35 by 2 whole square. Now the second one, which is this region, it will be pi by 2 into, now this is 21. So radius will be 21 by 2. Pi into 21 by 2 whole square. Okay. Then the third one, which is this one. So this will be pi by 2 into, what is the diameter is 28. So we'll just take 28 by 2 whole square. This is the radius. Okay. Now what we have to do here is, we have to add this one, first one, second one, the second one, and third one. No, second one we have to subtract. Please understand, second one we have to, this 35 by 2, this one has to be subtracted. So what we will do here is, this means this whole area plus this whole area, this we'll find out, we'll add them. Then we'll add the area of the triangle. Okay, then we'll subtract this area. I hope you got the idea. So what is the area of the triangle? Let us say half into base into altitude, that's 21 into 28. So what I'm trying to suggest here is, First we'll take the area of the fourth, that is second part, which I just said. Then we'll take the area of third, means this one, and we'll take the area of triangle, which is fourth one, and then the center one, which is the first one, has to be subtracted. This is what we have to do. Okay, so we have these all, so let us just add them. For pi by 2, we can just take outside. So we have to add 2, 3, 4. So we have 2, that is 21 by 2 whole square, and then 3, that is 28 by 2 whole square, and then we have this 35 by 2 whole square. This has to be subtracted, so I'll just say minus 35 by 2 whole square. And then we have this has to be added, so I'm just taking 1 here. This one is 1. Then we have the area of triangle, that is half into 21 into 28. So here is a very interesting thing, that when you take pi by 2, and this 21 by 2 whole square will be 441 by 4. This will be 28 by 2, so it will be 14. 14 square is 196. And then we have, this is 35 whole square, 1, 2, 2, 5. 2, 5 by 2, by 4. So if you see, if you compute this whole is going to be this addition, and this addition will be 1, 2, 2, 5 minus 1, 2, 2, 5, pi by 2. So this is eventually going to be 0. See, this will be going to be 0 ultimately. So only we are left with the half into base into altitude, which is going to come as 21 into 28, which is 294, and this is nothing but the answer. So this is the region we are talking about. So what we did, let me tell you again. We took this one, and this one. So 1, 2, 3, we just added them, and then we subtracted this first one, that is this one, from here. So we got this area, these two areas. In the figure shows the cross section of railway tunnel. The radius of OA of the circular part is 2 meter. If angle AOB, this is 90 degree, find the height of the tunnel. So we have to find out the height of the tunnel, and the perimeter of the cross section, and the area of the cross section. So here is the figure, how we are going to do this. First of all, this OA and AB, it is given that it is 2 meters. So radius is 2. This is 2, this is 2. Now when this is 2 and 2, and this is 90 degree. This is 90 degrees. So by Pythagoras theorem, we can use this. We can find out AB. AB will be simply equal to 2 square plus 2 square under root. That is 2 square into 2. So 2 comes out, 2 root 2. So what do we get? This AB as 2 root 2. Now when we drop a perpendicular here, if this AB is 2 root 2, what this will be? Root 2, and this will be root 2. Half of this. So half of this will be this one. This is half. Now in this triangle which we are getting, this is 2, and this is root 2. So what this side will be? Again Pythagoras theorem, root 2 whole square minus 2, this 2 whole square minus root 2 whole square. So 4 minus 2, that is going to be 2. And when we find out the root, it will be root 2. So this one is root 2. This one is root 2. So this is 2 because it is a radius, and this we just found out to be root 2. This is 2, and this we just found out to be root 2. So the height will be 2 plus root 2. So the height will be 2 plus root 2. Now the perimeter of the cross section. For that we have to find out this one plus this one. This one plus this one. AB we already know. So AB plus the major arc we have to use. Major arc. That is ACB, if you can say. So this major AB is already known to us, which is this one, which is already found to be 2 root 2. So 2 root 2 plus major arc. Major arc is what? See, this angle is 90 degree. So what this angle will be? It will be 270 degree. 360 minus 90 will be 270. So what is the length of the arc? Any arc of a circle is theta by 360 into 2 pi r. In this case, theta is 270. So 270 by 360 into 2 pi r. That is 2 into pi into r. What is the radius? 2. And 270 by 360 is nothing but 3 by 4. So 3 by 4 into 2 pi into 2. So 2 to 4, you get 3 pi. So just add 3 pi here. So 3 pi by 2 root 2 is the whole length from here to here. So it's a boundary. The perimeter of the cross section is this. Now in order to find the area of the cross section, what you have to do, you have to find the area of this sector and area of this triangle. And since this triangle can easily be found out using, because there is a triangle here and this is 90 degree. So this one, 2 and 2, half into base into altitude. This is base, this is altitude, because this is 90 degree. So half into base into altitude plus the area of the sector, which is this one. So area of the sector is what? Again, 270 theta by 360 into pi r square is the area of any sector. Theta here is 270 because we have to find out this one. This area I'm interested in. 270 by 360 into pi r square. The 270 by 360 is 3 by 4 into pi, that is, you can use pi directly, and r square radius is 2, so 4. 2 square is 4. So what do you get? You get 2 plus 3 pi. 2 from here, 3 pi from here. This is the answer. In this figure, it shows a kite in which BCD is the shape of a quadrant of a circle of radius 42 centimeter. Now ABCD, this ABCD is a square, and this is a triangle, isosceles triangle, right angle triangle also, because this is 90 degree. Whose sides are 6 centimeter long, so the sides are also given. Find the area of the shaded portion. So what we have to do, this is the first area, this is the second area, we just have to add these two areas. So what is the area of the quadrant? It is 1 by 4 pi r square. Theta by 360 into pi r square. Theta is 90 degrees, so 90 by 360 into pi r square, 1 by 4 pi r square. So 1 by 4 pi, that is, you can take it as 22 by 7 pi r square. What is the radius? What is the radius here? It is being given to us, which is 42. See, 42 is the radius. So 42 into 42. This is the first one. And now how about the second one? Because it's a 90 degree, and we know that these sides are 6 and 6. All the sides, these two this is an isosceles triangle. This side is 6, this side is 6, and this is 90 degrees. So half into base into altitude. So half into 6 into 6. This will come as 1386. This will come as 18. So the answer will be 1404 centimeters squared. In this figure, ABCD, this is a trapezium of area this much. In it, AD is parallel to BC, and angle DAB, this angle DAB, this is 90 degree. AD is 10, so let me show you this. This is 10, and this is 4. BC or CBE is 4. If ABE, this one is a quadrant of a circle, find the area of the shaded region. So before we go ahead, because there are certain questions like this, let me tell you that the area of a trapezium is half into sum of the opposite side. In this case, we have opposite sides are AD, opposite parallel sides. So AD plus BC, and then multiplying the distance between them, that is the altitude or height between them, that is AD. This is the formula we are going to use. So here the trapezium area is given. So let us use this half into AD. AD is what? 10. Plus, what is this side? BC, it is 4. And what is the distance between them? It is given 3.5. Is it given? No, it is not given. So we have to find it. So it is H. Let us say H. Why and how we are going to find H? Because we are given the area. So area of trapezium, we can equate it, and this will be 14, and 2 7s are 14. So H goes 24.5 by 7, and this comes to be 3.5 centimeter. So this is height between them or distance between them. Now find the area of the shaded region. For that, what we have to do? We have to find out the area of this trapezium, which is already given fortunately, and we have to subtract this area of the quadrant from it. So what is the area of quadrant? 1 by 4 pi r square. That is 24.5 minus 1 by 4 pi r. What is the radius here? Because this is given as 7 by 2, because 3.5 is what we got. See, this is the height, this is the radius also. This height and radius are same. So we get 7 by 2 into 7 by 2. This is 24.5. What do you get here? It will be 9.625 and this comes to 14.875 centimeters square. In this figure, ABCD is a trapezium with AB parallel to DC. Now, AB is 18 and DC is 32. And the distance between AB and DC, this is given to be 14 centimeter. Circles of equal radii, so this circle of equal radii, this A, B, C, D, they are being drawn. So all have the radius as 7. This way. This is 18, this is 32, distance between them is 14 and the radius is 7. All of them. Find the area of the shaded region in the figure. So what is the area of the shaded region? First of all, if you see that the area or the angle of the internal angle or interior, so interior angle of any of the quadrilateral sums up to be 360 degree. So you make any kind of, say, this quadrilateral, this plus this plus this plus this will be 360 degree. So if you see, if I combine these all, because the radius are same, so if the radius is same and I combine all of these, this will be 360 degrees. So 1, 2, 3, 4, these quadrants, if I combine them, they will form a circle. So essentially what we have to do, we have to find out the area of the trapezium and we have to subtract the area of the circle with the radius 7. What is the area of the trapezium? It is half into sum of the opposite side, that is parallel side, 18 plus 32, and the distance between them, that is 14. And we have to subtract it from what? What is to be subtracted? It is pi, that is 22 by 7, and r square. What is the radius of this circle? 1, 2, 3, 4. If you combine it, it will be 7 into 7. So what do you get? Here you get 350, here you get 154, and the answer comes to 196. From a thin metallic piece in the shape of a trapezium ABCD, in which AB is parallel to CD, this BCD, which is this one, BCD, is 90 degree. A quarter circle BC, this quarter circle, which is actually a quadrant, is removed. Given AB and BC is 3.5, so AB and BC are given as 3.5, so this is 3.5, this is 3.5, and DE, this is 2. Calculate the area of the remaining piece of the metal sheet. So this is 3.5, so this will also be 3.5. So one side is AB, so what we have to do here is area of the trapezium minus area of the quadrant. Area of the trapezium is what? Half into sum of opposite sides, 3.5 plus this is 2 and this is 3.5, because this is also 3.5, so radius will be 3.5. So 3.5 plus 2 is 5.5 into the height. What is the height in between? It is the distance between the parallel side. It is 3.5, and we have to subtract the area of the quadrant. We know that it is 1 by 4 pi r square. R is given as 3.5, so you just write it as 7 by 2. It is 7 by 2. This is what you have to do. So when you compute this will be 15.75. When you compute this is going to be 9.6, and the difference will be 6.125 centimeters square. In this figure, ABC is an equilateral triangle. The side is given as 8 centimeters. So side is given 8 centimeters. ABC are the centers of circular arcs of radius 4 centimeters. So all are 4 like this. Find the area of the shaded region correct up to 2 decimals. So what we have to do, we have a triangle which is already given as equilateral triangle. So area of the equilateral triangle minus area of these 3 quadrants. So area of 3 quadrants. What is the area of the equilateral triangle? It is root 3 by 4 side square. Side is already given, it is 8 square. And then area of 3 quadrants. So what this, we know that equilateral triangle has angle as 60 degree. So what is the area of any quadrant or any sector? It is a sector. Theta by 360 into pi r square. Theta is 60 here. So we have pi r square. This goes 1 by 6 pi r square. Now we have 1, 2 and 3 sectors here. 1, 2, 3. So we multiply it by 3. So it becomes 1 by 2 pi r square. So I'm just writing it 1 by 2 pi I'll take as 3.14, and radius of course is, the radius is 4 given in the question, 4 into 4. So this comes to 27.712, this comes to 25.136, so the answer will be 2.576 centimeters square. Sides of a triangle field are 15, this 15, 16 and 17. With the corners of the field, in the corners of the field, one corner buffalo, one corner horse, and the other corner, that is the third corner, we have a cow. We have a cow here. They have been tied separately. You can say the grazing length or the length of the rope is 7 meters for all of these, all of the three animals. Find the area of the field which cannot be grazed by three animals. So we have to find the area of the triangle and subtract these three sectors from here. So these sectors, let me tell you that I'll just take the area of the first sector, that is this one. So what is the area of this sector? I have to add these three, right? So area of, say, buffalo sector plus area of cow sector plus area of horse sector. So this area of sector is what? Theta by 360 into pi r square. So here let us take this angle as B. So B by 360. What I'll do is, because 360 and pi is coming again and again, so I'll just say, and this radius is also common there. So I can just say pi r square by 360 and this angle B, that is theta 1, angle B plus angle H plus angle this C. But if you remember, for a triangle, the angle sum, internal angle sum is 180 degree. So this accounts to 180 degrees. So this will be pi r square by 360 into 180 by 2. So pi r square by 2 ultimately. Pi is 22 by 7. Radius here is 7. So 7 into 7. And then we have pi r square. We have half. So this comes to 7, 7 cut, 2, 11 cut, and 11 into 7 is 77. So area of the three sectors is 77. So what we have to do, the area of the triangle minus area of the sector. So area of the sector is 77. Now we have to find out the area of the triangle. Because the different sides are given, we will use the Heron's formula. In Heron's formula, we add 17, 16 and 15. We add them and divide it by 2. So we get S. So A plus B plus C by 2, 15 plus 16 plus 17 by 2, which comes to 48 by 2, it is 24. Now we'll use the formula under root S, S minus A, S minus B, S minus C. And this is Heron's formula. We'll put S as this one, A, B, C as these numbers. So you get 24 under root 21. So ultimately this is 24 under root 21. Either you can compute it and subtract 77 from it, or you can keep it like this in meters square. So this is the answer. In the given figure, the side of square is 28 centimeter. The side of the square. Then we have radius of each circle is half of the length of the side of the square, where O and O dash are the centers of the circles. Find the area of the shaded region. So here the side is given as 28. And since this is 28, what will be the radius? Because it is 28, this will be 28 by 2, it will be 14. It will be 14. 28 by 2 is 14. So what we have to do, area of this first region, second region and third region we have to add. But this one and this, say, X and Y, this area which is the quarter quadrant will be added twice. So we just have to take the 3/4 of this quarter. And because these are similar, so let me take 1 and 2. 1 plus 2 is what? I'll come to this square part later. One is this quarter part, that is this part, and same is here. What is the quarter part? We know that the quarter part, or the quarter of the circle area, we can find out, that is 3 by 4 pi r square. And since we have 2 of them, we multiply it by 2. So 2 into 3 by 4 pi r square. So 2 into 3 by 4, pi is 22 by 7, radius is 14 into 14. And this comes to be 924. And now what is the area of this square? It is 28 is the side, so we add 28 square. Here 28 square comes to 784. And the answer will be 1708 centimeters square. In a hospital, the used water is collected in a cylindrical tank. So we have a cylindrical tank of diameter 2 meter. The diameter is 2 meter and the height is 5 meter. The height is 5 meter. Now, after recycling this, water is used to irrigate a park to hospital whose length is 25 meter and the breadth is 20 meter. So we have say this kind of arrangement. I'm not a very good my handwriting and my drawing is very bad, so I'm just trying. So this is the figure. So this water has to be put in here. When it is put in, the height will increase. So the volume of this is equal to the volume of this one. Volume of the cylinder has to be equal to the volume of this say shape. So we have to find out the height. What is the height of standing water? So we'll find out the area of this cylinder, which is pi r square h. Pi into r square is 2 square into h. Height is also given. This is equal to length into breadth into height. So 25 is the length, 20 is the width, and we have height. So what do we get? H equal to pi is, you can use 3.14 into 2 into 5. Then we have 25 into 20. So this becomes 0.0314. This is the answer. Height is this one in meter. So these were the question and answer of this topic. Thank you so much and take care of yourself.